The next manufacturer we're going to discuss is Conbraco. And talking about the Conbraco, we're going to be talking about Conbraco series of backflow assemblies. What I mean by series is the 40-100 series is a double check version. Recently, in the last about 2008, they decided to switch to a different model number designation where the 40-100 series is also known as the DC40 series. Why it's called a series is because every size has a different model number. In other words, 40-100 tells me that's a double check family of backflow assemblies from Conbraco. But the last digit will tell me what size it is. In other words, a 103 is a ½ inch, a 104 is 3/4, 2 inches 108, 6 inches 10C as in Charlie, 10 inches 410G as in George. So they went through the numbers and an alpha sequence to determine the specific size of that particular model number. So 40-100 series are all double checks. Last number tells me what size it is. Besides the last digit showing the size, there's also 2 or 3 digits after the size designation, which are called suffix numbers. And these have designations that show different things also. The 1 is less ball valves, 2 is with ball valves, the 4 is a union end with ball valves. The A letter designation there means replaceable seat, because in the small sizes, 3/4 through 2, they made this in both a replaceable and a non-replaceable seat version over the years. And if it's the A designation in the 2 inch and under, that tells me it has a replaceable seat. So it's called a 40-100 series because 40-100s are all double checks. Last digit is the size, and the suffix number tell me the trim that's on the outside, whether it's ball valves, and on the larger sizes it'll be NRS and OS and Y shutoffs. The smallest version of the 40-100 series is the ½ inch double check, known as the 40-103, the 02 designation, meaning it has the ball valve shutoffs. This was actually the same as their 40-300 dual check, which they used by putting ball valves and test cocks on it and making it into a ½ inch backflow assembly. This was their ½ inch double check assembly for a while. They later created a new version called the 4S series, which we'll talk about in a minute. But this was a Y pattern, poppet style check, disc holder, spring, cover coming off the top like that. The 3/4 through 2 inch size was originally produced in a Y pattern poppet construction like this also. Bronze body, poppet style checks, inlet outlet shutoff as you can see here. This Y pattern in the 3/4 through 2 was discontinued around 2002, and they went to a top entry design. The top entry in the 3/4 through 2 inch looked like this, and the A series, the T series with the test cocks on the side. They also had the 99T series with the test cocks on the top, but they went to a top entry design on the double check sizes in the small 3/4 through 2. The rubber repair parts are similar in the Y pattern or the top entry style. Had a replaceable check seat. There was a non-replaceable check seat version also. It was a glass-filled rail sealed by an O-ring, check disc holder, check disc, spring, and cover cap. So this is the Y pattern version. Parts similar in the top entry version. The large sizes, meaning 2.5 through 10, were produced from about 1989 to about 2003. They utilized a ductile iron body that was fused epoxy coated, check covers on the top. Check covers could be removed during the repair, and the check spring load was contained for the average repair. In other words, when you took the cover off, the spring was contained. It did not have to be released for the average repair. Inlet outlet shutoff bolted like this. The 2.5, 3, and 4 inch had a one-piece body design, as you can tell by this picture, where the 6, 8, and 10 inch had a 2-piece body. In other words, they were bolted together through the center of the single checks. So 2.5 and 3 and 4 were a 1-piece body, 6, 8, and 10 were a 2-piece body. Here's what the larger sizes, 2.5 through 10, looked like. This being the small 2.5 through 4. Check seat was bronze, was screwed into the body, sealed by an O-ring. The check assembly came out in one piece like this. The spring was contained for the average repair. The spring did not have to be released for the average repair. It may need checking periodically. We'll talk about that in the repair process. One nut holds the disc retainer and the disc into the disc holder. For the average repair, you remove the one nut, replace the disc, and that's what it takes to rebuild this particular check assembly. In the double check family, they also produced a double check detector assembly, which was called the 40-600 series, produced in sizes 3 through 10 inch. Same different stories where the 40-600 series, the last digit will tell you the size, and the suffix numbers on the end will tell you the type of shutoffs that were with it and the other trim that came with it. So the 40-100 series double check and the 40-600 series double check detector assembly. Let's go ahead and take it apart and see what it looks like. We're going to go ahead and take this apart and put it back together. Disassemble is going to be unscrewing the check cover. There will be spring tension underneath. Removing my cover, removing my spring, removing my disc holder. This being the non-replaceable seat version. The replaceable seat version utilized the plastic material, glass-filled rail for that. Rebuilding this check assembly, one screw holds a disc into the disc holder, spring, and cover. Now, this is probably the most common check design on the market today, 2-inch and under. Not because conbraco sold some more than anybody else, but because, as I said earlier, there are about 6 different manufacturers that produce almost this exact same model. So I want to spend a minute to go over this model to show the intricacies of how it works. This disc holder sits into the cap like this with the spring squeezed. So I'll take the spring out just for conversation point at this point. And the normal flow of water in a closed position would be like this. So the spring would be extending it to a closed position. As there's a demand for water, the check disc holder will slide into the cover. This portion here where it slides into is our guide. As we said earlier, the guide is the most important part of most components, and that's the part where this disc holder slides in as there's a demand for water. As the demand for water stops, pressure increases, it goes to a closed position like this. Why it's important to know how that moves back and forth is because this unfortunately is one of the most misrepaired assemblies on the market. Again, because there's so many on the market, here's a normal scenario that a lot of people will do. They'll take sandcloth and they'll just sit there and shoe shine this to get that smooth so that they'll get all this, any kind of scale that's off of there. They'll see this little hole in there and they'll get themselves a copper wire brush or something in there to clean that out. They'll say, oh, this will slide better. I know, I'll just fill this up with grease so it slides better in and out of there. All of those things cause this check assembly to wear out faster, and I'll show you why. This disc assembly, as I said, is designed to travel in and out of the cover. The tolerances between the outside diameter of the disc holder and the inside diameter of our guide is literally within thousandths of an inch. It's that close of a tolerance that this has to abide by. And it makes sense because as this check assembly moves in and out, it has to hit the center of that seat. If that guide had a lot of wiggle room and moved back and forth, the disc wouldn't hit the center of the seat. So the tolerances, as you can see, are very, very tight. I can barely move that disc holder within that guide mechanism. Second thing is that the disc holder is hollow, and that's important. They didn't do that to save 2 cents of plastic. It's there for a specific reason. And at the base, there is a corresponding breather hole right here. This is very important because how does this work? Just like this. So in a closed position with the spring extended through here, water is inside the body like this. This area fills up with water. Water also goes in through the breather hole right there, and it also goes in the area between the ID of the guide and the outside diameter disc holder. So in essence, there's water in the center of that stem. As there's a demand for water, what happens to the stem? It pushes into the cover. Well, what happens to the water inside the cover? Well, it comes jetting out in 2 places. One at that breather hole right there, but also right here up close at the difference between the ID and the OD of those 2 pieces. So water jets out across here as it goes into the cap. What is that jetting water? Well, basically that's a lubricant. In other words, it puts a jetted coating of water as this moves into the cover to make it slide easier. When the check assembly goes to close, pressures build back up, and then the spring overcomes to close the check assembly. As the check assembly draws down out of the guide, it siphons the water back in through those 2 areas. So in essence, every time it moves in or moves out, there's water jetting in and across this area and in and out of that breather hole to make sure that that check assembly moves smoothly back and forth. That's important to know because think about it. If I do take sandpaper and wipe it along the outside here, what have I done? I've created a small little ridges on there. Is that going to restrict or make friction as this moves in and out? Of course it is. This area in here, if next time you fix one like this, stick your finger in there. You'll see that that area is actually what's called honed or polished. In other words, it's very smooth inside here. It's not just a rough piece of brass that's drilled, but it's actually a smooth or polished piece of brass. And the purpose of that smooth, polished piece of brass is so that as the disc holder slides in and out of there, traveling across a jetted coat of water, it will move smoothly. So any interface of putting sandpaper on here or any kind of wire brush in here is going to make this wear out faster. It's going to reduce your differential across that check, causing it to wear out faster. So be very careful when you're working on this design. No sandpaper, no wire brushes, and when you put grease on the assembly, be careful where you put it. All the manufacturers are starting to include the little pillow of grease. You don't have to buy grease in big tubes anymore because each kit seems to have these small little tubes that we need for the repair. But where is the grease used on this particular model? One place and one place only, our cover O-ring. That's the location where the grease goes. Never any grease on the disc holder and definitely no grease inside of our guide. So that's how this check assembly operates. This is going to apply to several other manufacturers also. And making sure we understand how it works is critical to know how to repair it. Now, in our repair process, earlier we said when we fix a backflow assembly, when we take it apart, we want to take it apart and we want to put the first check parts over here and the second check parts over here, have them ready to go back in the body and maintain them. Why is it important to keep them separated when the parts are exactly the same? Well, the reason is because let's assume when we tested this assembly, let's say the first check was supposed to be 3.0 and it did test at 3.0. Second check was supposed to be 3.0 also, and it tested at 0.9. So we know at 0.9 it's below a minimum value of 1 and it has to be repaired. We go ahead and replace the rubber repair kit, put it back together. First check, still 3.0. Suddenly the second check is up to 1.1. Does that meet original factory specifications? Well, we check our flow chart and we see that it's supposed to be 3 pounds. So yes, it's above the minimum of 1, but it's not to the maximum level, which in this case would have, using 3 as an example, would have been the number that that check assembly should have appeared at. So now what we're going to figure out is why is the number 2 check so much lower than the number 1 check, even though it's above a minimum after we've repaired it? Well, one of the problems with repairing a backflow assembly like this is that, or any assembly, is we don't know what somebody did before us, whether they fixed it right or wrong. We don't know if there's been a water hammer condition, meaning second check got slammed closed. Somebody put excessive pressure on it, thermal expansion, pumps, anything like that. So we have to do a little bit of detective work. So what I would do at this point is take these 2 checks and I would swap the disc holders. In other words, take the first check and put it in the second check, put the second check disc holder in there, keep the springs where you took them out and put it back together. And see if moving those disc holders showed the change in numbers. In other words, if suddenly the first check is now 1.1 and the second check's 3.0, we know there's something wrong with that disc holder. Now we can investigate the disc holder closer. I've got a few disc holders here on the larger sizes, 2-inch, which are a little easy to see. And one of the things we're going to check for is any wear and tear. This particular here is a good one, straight up and down. You can see this one is slightly worn out on the edge. Here's one that's greatly worn out on the edge. So if there's a wear and tear on that edge, as that disc holder slides in and out of that cover, it'll be loose. Loose tolerances won't seal as well. Lower differential can cause a problem. This being a worst case scenario, this being just slightly damaged. What happens if thermal expansion hits that backside, or we have a pump scenario, or something with solenoids creating hydraulic shock? Could the disc holders actually be broken? Well, yeah, this would be an extreme case, wouldn't it, where it was broken in half. The usual case is where it tends to bend outward, and it's slightly bent out of that disc holder. Usually not perceptible to the eye, but when you change the disc holders and you see the numbers change, that can tell you that sometimes these disc holders are bent and they're no longer flat. And what that means is we're trying to take a rounded disc holder and sit against a flat seat. Again, we're not going to be able to seal as well. So looking for degrees of wear can be small, can be extreme, and the actual most extreme can be broken in half like that. So checking those 3 things is the kind of stuff you want to look at those disc holders, and you maybe end up replacing that disc holder. What happens if I swap those 2 parts and the numbers don't change? What's the next thing I'm going to look at? Well, the next thing, what did I always say was the most important part of that component? It's that guide. Switch the covers on both sides and see if the number follows that guide. If we've done that, it doesn't follow, then you might look at your spring tensions and see if maybe one of the springs is one of the problem. But usually the spring is the last thing you have to worry about. One of the problems with the spring, well, we'll talk about when we put it back together. Okay, so we've got this rebuilt. We've figured out what was wrong, got it replaced, repaired what was appropriate. We're going to go ahead and reinstall that second check, and I'm just going to put it in this configuration just to show you a demonstration. You want to be very careful when we're going to install this, because this check assembly is designed to work in a poppet configuration, straight up and down. And this is that cylindrical type of compression spring we talked about that gets its load from compression. But the important thing on a compression spring, like we talked about, is making sure it's straight up and down through its travel. If it's hip to one side like that, or slightly bent to one side, you're not going to get your optimum load of that check assembly. Now, when we go to put the cover on top, obviously we can't see what we can in a cutaway like this. But looking at a cutaway, you can see that as I go to tighten that cover, you'll notice the spring is turning. Well, that happens very regularly. As you're twisting the cap, of course the spring is going to twist. And one of the problems is as that spring does twist, as the spring twists, there is half a chance that that spring can catch on the cover as I twist into it. Twisting it can actually bend that wire, or can actually cause it to hip off to one side just like that. So When we go to reassemble this type of assembly, we want to put it back together. We want to bleed the air out through our test cocks. We want to make sure we have all that properly removed. And before I go ahead and hook up my test kit, I'm going to open that test cock a little bit more than air. I want to actually bleed water out of all three of the test cocks, meaning number 2, 3, and 4. Why? Reason is I want to flow some water because I want to get that disc holder off of its seat. In other words, it could be bent over like this. It could be twisted from that spring. By flowing water through that check assembly, it lifts the disc holder off of the seat and actually will cause it to straighten itself out and twist what goes back in place straight up and down. Helps you align the check assembly by stroking it once or twice before we go ahead and hook up our test kit. Then you go ahead and hook your test kit and see how that check assembly properly operates. This is the conbraco 40-100 series in the 3/4 through 2-inch size. Talking about the larger conbraco 40-100 series, or DC40 series as we mentioned. The backflow assembly is constructed of ductile iron, fused epoxy coated. It's removing the cover from the top. The check springs are contained for the average repair, so that means I don't have to release spring tension for the average repair. Check assembly comes out in one piece. Seat threads into the body, sealed by an O-ring. You can see the O-ring seal underneath. Tool will go in and unscrew the seat and remove it if you have to remove the seat. Again, check assembly will come out in one piece for the average repair. And the average repair consists of this, taking off the one nut. This is obviously 2.5 through 4. Taking that off, 6 through 10, we'll have 4 little bolts across there. And that's what you're going to do for the average repair. But of course, if it was an average repair, we wouldn't be able to do it, would it? First thing when we take this disc holder out of the body, we want to look at a couple things. One, you'll notice that there is a wrench flat on the bottom of the stem right here. Very important that that wrench flat is there because that's how this check assembly is put back together. I'll show you in just a second. You can see it right there. I want to make sure that that wrench flat is all the way up like this so that I know my stem is in there. You'll notice I can turn this stem. Well, the stem is threaded into the disc holder, and the more I turn it, you'll see that those threads start appearing. We do not want to see those threads. We want to see that wrench flat like that so that all we see is the wrench flat and no threads. That's the position it should be in. But again, you want to check it before you take it apart. As I said, taking it apart was just taking the one nut off like we said. But let's assume we replaced the disc. Let's say we put a new disc into it and replaced it and we still had problems. Checked our seat was okay. What else could be causing problems? Well, first thing, let's look at the construction of this check assembly. You notice that there's a stainless steel rod that runs through the center of our disc holder and our spring retainer. Well, if we have that piece of stainless steel going through the stem, somewhere there's got to be a seal in there. It makes sense because if we had nothing between this stem and this disc holder, the water would travel right through there, causing a check assembly to leak. A lot of people assume a check assembly only seals on the top portion. After all, this is the part that sits on the seat, right? Well, that's not true in all cases, as we discussed earlier. Yes, the seat sits here, but it also presses down to seal on the bottom half of the disc on the flat underneath it. So if that's holding properly, we separate those pressures on both sides of that check seat. Back to that stem scenario. If that's working properly, where else could the water travel through? Well, you could see it could travel through that stem right there. As I said, for the normal repair, you do not have to release the spring tension. But after I've changed the disc, checked everything else, made sure everything's working right, the thing I want to remember is that that O-ring sits in there. And this is not needed for changed for the average repair. But if I do have problems, or if I notice that those threads were sticking out like this when I took that stem apart, I'm going to be very careful to look at that O-ring that sits right there in the middle of that stem. Because if that O-ring is no longer squeezed into its retainer, properly sealing off those two areas, the check assembly will leak just as bad as if the disc was leaking or had dirt and debris on it also. So there's that hidden O-ring, as I like to call it. And here's how you can see how that stem threads into the disc holder. And again, for the average repair, when I take it apart, all I'm going to do is touch that and make sure that it's tight. It should be tight along there. As long as it is tight and then the O-ring is sitting in its slot, we should not have to release the spring tension for that average repair. But if after we've changed our disc and gone through our repair scenarios, don't forget the O-ring that sits inside that stem assembly. Otherwise, our normal repair is going to be, hopefully, one little nut like this, new rubber disc, having it ready to go back inside the body, like that. Cover back on top. This is our 40-100 series in the sizes 2.5 through 10. The 40-200 series is the reduced pressure principal assembly. The newer designation is the RP40 series. Just like with the double check series, the last digit of the 200 part denotes the size, so a 40-208 is a 2-inch, and then the suffix numbers on the annual denote the trim that comes with it on the small, meaning ball valves, large, meaning NRS, OS, and Y strainers, and those type of shutoffs. So like I say, you'll see a different model number for every size in this conbraco series, which can be confusing if you're not sure what you're looking at on those model designations. Production began about 1989. All assemblies, 1/4 inch all the way up to 10 inch, are still in production. The 3/4 through 2 inch was a bronze body construction. Check valves pointing up through the top, relief valve mounted on the bottom, inlet outlet shutoff. Number 2 test cock mounted on the relief valve cover, so we want to be careful when we're opening that for test procedure reasons that we don't dump the water off the relief valve. And you can see test cocks 3 and 4 located here. Here's a breakdown showing the check valves from the top with the replaceable seat version. The relief check seats can be screwed into the body, sealed by an O-ring. Special tool needed to thread them in and out. Disc holder assembly with our disc holder, disc retainer, disc screw, check spring and covers on the top. Relief valve is mounted from the side. Relief valve cover, here's our relief valve seat, which screds into the body, does not have to be replaced for the average repair. Our relief valve stem, which comes out in one piece, is disassembled. One screw holds this diaphragm retainer and the spring into here. Our stationary guide with our stationary guide O-ring. Our relief valve stem with stem O-ring. Relief valve disc retainer, disc screw. Diaphragm and relief valve cover. The larger sizes in 2.5 through 10 utilize that same ductile iron body as we saw in the 40-100 series, but you'll notice the relief valve is mounted underneath the check bodies. So here's our high pressure sensing line coming here, and our low pressure sensing line coming through here. Our relief valve discharge on the bottom. Inlet outlet shutoff, number 2 test cock, 3 and number 4 test cocks on the top. As before with the 40-100 series, the disc changing the checks does not require the spring load to be released. Can be taking the cover off. The spring will come out in a contained fashion and does not necessarily have to be released for an average repair. Relief valve mounted from the bottom. The relief valve body does not have to be removed from the body for the repair. Just moving the cover and pulling the stem out from the bottom is usually good enough. And that's the 40-200 series. They also produced a reduced pressure detector assembly, the 40-700 series. Utilizing the main valve is a 40-200 series. And the bypass, as you see in this particular case, is a 40-200 series bypass. So the RP is the 40-200, the RP detector assembly is the 40-700 series.